I feel like everyone's got their own way of ripping up strips of wood to make an ingrain cutting board. But this video really isn't about that process, because I don't think it's really the interesting part. The more interesting part is the design, shown here in Autodesk Fusion. And the design was heavily influenced by this bit, a tapered ball nose. And before I did any design work, I had to do a bunch of tests to figure out what fit parameters would work best for this bit. I also wanted to figure out the smallest line width that I could actually create. I may do a dedicated video about how to design VBit inlays for a tapered ball nose, but I'll throw a few tidbits in here and there when I make this project. One interesting thing I did during the glue up was to come up with these L-shaped cowls to help keep the ends aligned and flat. And I simply remove them after I have a few clamps on and everything aligned. If you're curious about the wood, this is cherry. After the glue dried, I planed it and cross-cut a bunch of pieces to a rough size of 1.7 inches. And it was just a repeat of the same process before, but I didn't really have to get it perfectly aligned. But notice that I did wipe all the glue off the top. And I didn't have to do any additional prep. I just mounted it upside down on my spoil board using some side clamps to hold it on tight. Once I verified it was cutting right, I threw the split dust boot on to keep chips at bay. Now, one of the things you don't see me doing is touching off the bit or finding the origin of the workpiece. I have dogs that define the work offset, and I just store and reuse them again and again. And I don't have to touch off my bits because I have a tool changer. But more importantly, I use the bottom of the workpiece as my Z0. Even if you touch off a bit on each tool change, you should be using the bottom as your Z0 and touch off on the spoil board. Just trust me on that. Now, I had to use a pattern router bit to remove the area that the clamps were located. I usually prefer to do this in the CNC, but I would have had to waste more material to do that. At this point, I have a very precise size, a flat bottom, and nice finger grips. I can mount that bottom down on my CNC table, and I ensure the origin is pushed tight against my dogs. This is a good shot of the side clamps that I mentioned before. You can 3D print these, and if you happen to hit the plastic with your bit, it's no big deal. I want to ensure the piece is perfectly flat on the table, as the next step is the base for every other operation. Next, I machine the top of the board. My toolpaths are all carefully planned to avoid any chip out. I first do a profile pass, trimming off about 50 thousandths of an inch. I then surface the top with a facing operation, but I leave about 20 thousandths of an inch of the stock on top, and this will come into play later. So I wrote this plugin for Autodesk Fusion called VBit Inlay. It easily automates the process to create an inlay, the matching plug, and all the toolpaths. I've been working on it a lot lately, and recently I did a bunch of updates to allow people to easily create designs like this. The plugin is shareware, meaning you can download it for free and try it as long as you want. If you like it and use it, you can get a license for $5, which is really way cheaper than a lot of the alternatives. In Fusion, you can set a tapered ball nose up as an engraving bit, and it will happily use it for the engraved toolpath. Now, I made two mistakes in this project, and I'm pretty sure that I'm making the first mistake here when I'm prepping the stock for the first inlay. It's a problem you can't see. And it's probably because I started with some 8/4 walnut, and I should have rough cut the lumber to size and let it sit in my shop for a few days before final milling and gluing it up together. This will later come back to haunt me, and I'll talk about it more at that point. I'm gluing up these pieces at 5/8 of an inch thick. I'm attaching the plug down to my table, and it's completely rough. I see a lot of people playing their stock flat, and that's completely unnecessary and can introduce inaccuracies. Again, this really assumes that you're going to be touching off on the spoil board and not the top of your stock. And the trick is to machine the top of your plug stock perfectly flat as the first operation. Then you can VCarve the plug with the tapered ball nose. I also cut the plug profile out with the CNC, and as I was doing this, I was kind of working through some parameters to make sure it wouldn't produce any fuzziness. In fact, one of the best parts I've seen about moving to a tapered ball nose is that it leaves a really clean cut with virtually no cleanup required. The bit has two flutes and is upcut, which both help with quality and especially compared to a single flute 15-degree VBit like something that I was using before. Something that I'm experimenting with is using the air compressor to blow out excessive glue, and also just to make sure that I've got enough glue in all the little tiny holes and pockets. Because if you blow some of it out, you'll know right away if you missed an area. Now, I always see everyone put the plug in and then tap it down with a mallet. And honestly, I don't think this is going to really do much because you're going to be taking it over and putting it in a press right away. And I feel like using a press is a real essential part of getting good inlays. You really squish the plug down in and compress the fibers in some areas where it just wouldn't fit perfectly otherwise. Now, this is one of my later plugs that I'm pushing in with the press, and I get down my side and I really look at it and observe it getting squished in. I want to make sure that the gap that's above it, the surface gap, is consistent all around it, and that it's actually the size that I designed, because if it's too large, you know that it's not going down deep enough. And sometimes I will actually loosen the press and squish it in a different area to ensure that I get all the parts equally squished down. I've found that I have to wait about 48 hours before I surface the plug. It has to be in the press for only a few hours, but the problem is the wood absorbs a lot of the glue moisture and it will cup upwards. It takes about 48 hours, 2 days, for it to become flat again. And you really want it to be flat before you surface it again, otherwise you're just going to cut off too much of it. And believe me, I've made that mistake. So that clean cutting tapered ball nose left a really nice finish, but I did have to remove a few fuzzies by hand, just little areas that it didn't quite get. Now, there are little islands of walnut left by the design, and if there was any actual glue gap left down there, the islands would just fall out, so it's really important to strive for a zero glue gap. I made the plug out of maple, and it was fairly complex. It took about 4 hours to machine the entire plug shape. My favorite part of the whole operation is the final profile pass, which I use a upcut bit to do and leave tabs. And the tabs are so small that they just snap right off. Now I take a careful look at the plug and the inlay, the female pocket, and I try to think about areas that are really tiny, where the ball nose didn't hit the bottom and show the actual cherry through. And that means the plug might actually have an issue. Some of the really thin designs might be part of the problem. And this issue can be seen in the simulations in Fusion. This is the small fin plug inlay, and it's one of the smallest details in my design. The plug goes to the full depth and has some angles on the edges at the top of the plug or the bottom, which will actually be inserted in. I can simulate the inlay pocket, and Fusion lets you do a section analysis to see how it's going. The bit is not going to the full depth for some small details, and the plug would bottom out early in areas like this. Now I can mitigate this a bit by trimming the plug a little bit. A little bit can go a long way, and with a steep ball nose angle, it really shouldn't be too much of an issue. And the reason the female pocket doesn't go to the full depth is because the design width is too narrow for the bit to fit, and the VCarving engraving algorithm lifts the Z up. I found that about 40 thousandths of an inch is the min spacing I can get and have enough meat to go into the pocket. I could design the spacing to be the bit's diameter at the desired full depth, but I want fine details. That's the whole point of VCarving. So after waiting another 48 hours, I could surface the top again. And this is when things started to get real exciting. The wave design was looking fabulous, and stopping at this point would produce an awesome cutting board. But I kept going. This is the background for the fish, and one of the considerations for this part of the design was to make sure I didn't have any of those thin spacings. They would potentially cause the plug to not seat all the way down, and you really don't want that to happen when you're going to machine it again. If those islands aren't glued down the middle, they will simply fall out. The main interior of the fish was done with maple. I'm a big fan of domestic hardwoods, so most all my work will focus on cherry, maple, and walnut. Once I popped the fish interior plug out, I started examining the areas and figuring out what might not seat all the way down. There were a few of those thin areas that I could pretty easily trim a little bit to make it seat a little bit better. But a sample fit showed that the eye was causing it to not seat very well. I thought it would be best to glue that part in separately, so I cut the eye out and covered up the eye socket with some tape to avoid getting any glue in it. And indeed, it did seem to fit a lot better once the eye wasn't on it. So like before, I put a bunch of glue in the pocket and put the plug in, took it over to the press, and squished it on down. I let it stay clamped in the press for a few hours, and then I took it out and glued the eye in. And the eye pressed down just as far as the rest of it, so maybe I didn't have to do the cutout. Now, my initial thought with this project is that the fish would be a rainbow trout and would have a red stripe on the background made out of cherry. So I glued the cherry plug into the back of the fish, waited for it to dry, and then machined it back off to get back to the same starting point. Next, I decided to do the fin interior inlay with maple. And even though it is the same wood as the other interior part of the fish, I felt like it needed its own step, as the thin parts may have caused some issues with the larger part of the plug seating correctly. I made a mistake, and my stock had a slight offset in it that I didn't realize, and so my cuts are all a little bit too far this way, only about 10 or 20 thousandths of an inch. I can actually look it up, but it makes everything off just a little bit. There's a few things I could do. I could just go with it and glue in the next piece and then glue in my other parts, or I could start over. And I think I'm going to start over by cutting out the fish outline again and going with that. I also am not sure if I like this being dark, so I might change that to be or change that from cherry into walnut, because I think the stripe would look better with walnut. So I used the CNC machine to basically erase this mistake by machining that fish outline again. It also gave me a chance to analyze how everything was seating, and everything was seating all the way down, which is really good. This did set me back a little bit, but I went ahead and glued in another fish background with walnut, and then I did the interior with maple again, and just did as one inlay. The next time I machined the fin's interior, I double-checked everything to make sure I did not make any offset mistakes. I cut all the fin pieces at once, and then I cut them apart on the bandsaw. They had some fine detail lines, so I took a little time to trim the ends a little bit to ensure they would seat far enough. These plugs were pretty small, so I only waited 24 hours for the glue to dry before machining off the top. Now, things were looking pretty good, and this would have been another great place to stop. But I wanted to take it even further. I machined a bunch of tiny holes in the back, and I did a corresponding plug for it. I wasn't sure how well this would seat, but it seemed to do fine. The hardest part was just lining it up so I didn't break off any of the little tips. And of course, I also did a walnut plug for some other little tiny dots and holes. I'm pretty amazed that this all lined up really well, and the only tidbit of information that I can give you, don't hesitate to put some glue on the plug itself, particularly if you can't get the glue all the way down in those tiny little pocket holes. Just put in the plug, no problem. At this point in the project, my dust collector motor died, and so I was having chips go everywhere, but I still wanted to finish stuff. No matter how careful you are, I feel like there's going to always be some discrepancies in the heights when you're continually machining the top, and this one was no exception. So I did the design where it was 20 thousandths of an inch deeper than it really should have been, and that way I could go ahead and take off 10 thousandths of an inch to reveal the actual design. And then the last 10 thousandths or so could be used to sand off the machining marks. If you don't account for this, your lines will become thinner and thinner as you take more off the top. I wanted the finished design to be true to my designed size that I did in my drawing. Sanding is like a cascading effect. I use the CNC to get the top flat, then I use the drum sander to remove the CNC marks, then I use the random orbital sander to remove the drum sander marks. So here's that first mistake that came back to haunt me. I got some checking, some cracks in the walnut. I've heard a lot of people tell stories on why they think this happens. Now, it only happens because of a change in the moisture content in the wood, and that's it. Too big a glue gap under the wood could capture some wet glue for a long period of time, and it could cause this to happen. But that's not the case here because I know I have no physical glue gap under that walnut. I think the 8/4 walnut I started with had a higher moisture content in the middle, and I didn't wait any time before gluing up the strips and ripping them into 5/8 of an inch thick and gluing up the end grain cutting board plug stock. I should have given them a few days for the moisture level to acclimate in the wood. It's also possible that the wood already had the checking in it before I started, and I just didn't notice. I've heard some people say that raising the grain can cause some checking, and I really don't think that's the case because you're adding a superficial amount of moisture to the wood and it's drying off really fast and it's kind of equally applied. I had sanded it to 220, raised the grain, and then sanded it again with 220 before applying the finish. This is just a cutting board oil, and I put some on, let it soak in for a day, and then I buff it up with some beeswax to give it a little bit of a shine. I started this project about 2 months ago. I spent a lot of time on the design, and I worked a lot on the software for the VBit Inlay plugin to make it easier to generate toolpaths for a complex inlay like this. I'm pretty happy with how the project turned out, and I'm currently in the process of making a second one. I may eventually offer them for sale, so if you're interested, let me know. If you want to try to make one yourself, I'll have the files available on my website too. Thanks for watching.